Hey guys, welcome to Chem Galaxy. So today I'm going to continue my topic of named reactions, and today we are going to study about carbylamine reaction. Alright, so in this video I'm going to explain you the carbylamine reaction, and I'm also going to explain the mechanism of carbylamine reaction. Alright, so stick around, the video is very important for all of you. Alright, so now let's start. So as you all can see, the heading is carbylamine reaction. Alright, so before getting into the reaction part, I am going to first explain how to determine whether a amine is a primary amine, a secondary amine or a tertiary amine, because there is a bit confusion or there is a bit different way to determine whether amine is a primary, secondary or tertiary. Because for example, if you take alcohol, so if you want to determine whether it is a primary, secondary or tertiary alcohol, so you simply have to look at the carbon atom through which the hydroxyl group or the OH group, which is particularly an alcoholic group, is attached. Alright, that I mean to say that if the OH group is attached to a tertiary carbon atom, so it is a tertiary alcohol. Alright, if the OH group is attached to a primary carbon atom, it is a primary alcohol. Alright, but this is not the case in amines. Alright, now amines are considered to be a alkyl or an aryl derivative of ammonia. Alright, ammonia you all know, NH3. So it is an alkyl or an aryl derivative of ammonia, which means that if we replace one hydrogen of ammonia from alkyl group, for example R, alright, so the resulting compound will be RNH2. Alright, it is known as ammonia or amine, sorry, it is known as amine. So you see the hydrogen has been replaced by an alkyl group, so the amines are considered to be an alkyl derivatives of or aryl derivatives of ammonia. Alright, so how to determine whether a amine is primary, secondary or tertiary? So you simply have to look for the number of hydrogens which has been replaced by an alkyl group. Alright, if it is an amine in which the number of hydrogens replaced is only 1, then it is a primary amine. If 2 hydrogens of ammonia have been replaced by an alkyl or aryl group, it is a secondary amine. Alright, and if 3 hydrogens of ammonia have been replaced by an alkyl or aryl group, it is a tertiary amine. So I have shown you some examples also, so I will explain it from there as well. So you see that, see my cursor, it is a primary amine, the heading is primary amine. So you see the examples, you see in each of the example there is a replacement of one hydrogen from an alkyl group, alright, or an aryl group. You see this is NH2, see my cursor, this is NH2. So basically in ammonia is NH3, so one hydrogen has been replaced by a methyl group. Alright, so CH3 is a methyl group, so hydrogen has been replaced by a methyl group, so and only one hydrogen have been replaced, so it is a primary amine. Same case goes here, you see this is, alright, in this also you see only one hydrogen have been replaced by the above group. Alright, only one hydrogen of ammonia have been replaced, so this is also a primary amine. Same case goes here also, you see one hydrogen have been replaced by a phenyl group, so it is also a primary amine. Alright, so this is how you can determine whether it is a primary amine. So now let us see the secondary amines. So you see in the secondary amines, you see that this is the NH, see my cursor, see, this is NH. Alright, now in ammonia it is NH3, here it is NH only. So this means that 2 hydrogens have been replaced. Alright, this means that 2 hydrogen have been replaced by a methyl group or by any alkyl or aryl group it can be. So it is a secondary amine. 2 hydrogens have been replaced, so it is a secondary amine. Alright, same case goes here also. You see that 2 hydrogens have been replaced by 2 phenyl groups. Now in tertiary amine, you see here it is only nitrogen. Now in ammonia it is NH3, so 3 hydrogens. Here it is only nitrogen, so this means that 3 hydrogens have been replaced. Alright, so this means that it is a tertiary amine. Alright, so this is how you can basically identify whether an amine is a primary amine, secondary amine and tertiary amine. It is a quite different way from usual way to determine whether it is a primary compound or a secondary or tertiary, but it is important to remember, so keep this point in mind. Now let us come back to our reaction part. So first of all, I am going to tell you some important points about this reaction. Alright, so that's I have written also, so I will first read it out and then I will explain it. So the first point is that both aliphatic and aromatic primary amines give this reaction. Yes, this point is very important, that carbylamine reaction is given only by primary aliphatic and aromatic amines, not secondary and tertiary. Alright, this point should be kept in mind. The second point is that only that secondary and tertiary amines, both aliphatic and aromatic, do not give this reaction. Alright, so basically because only primary amines give this reaction and secondary and tertiary does not give this reaction, so it is the carbylamine reaction is a reaction to distinguish between primary amines from secondary and tertiary. Alright, if you are given with three amines, for example primary, secondary and tertiary, and when you will perform carbylamine reaction, so it will be clear that which one is primary, which one is secondary. Alright, because one will give carbylamine reaction, one will not give. So basically it is a way to distinguish between a primary amine from secondary or tertiary amine. Alright, so that's what is the third point. So this reaction is used to distinguish between primary amines from secondary and tertiary amines. Alright, now the fourth point is that the isocyanides formed have very unpleasant odor. Alright, so the isocyanide which you will get in the carbylamine reaction as the product, it has a very unpleasant odor. Alright, so if you get a very unpleasant smell, alright, so this means that the reaction has happened and the amine was primary amine and the reaction happened and it formed a isocyanide or primary isocyanide, and it have a very unpleasant odor, alright, or unpleasant smell. Now let us see the reaction. Alright, so you see the reaction somewhat looks like this, that it is a primary amine RNH2, it is a primary amine. Alright, we react the primary amine with chloroform, which is CHCl3, and alcoholic KOH. Alright, I am repeating it, that the primary amine is reacted with chloroform, or the primary amine is heated with chloroform and alcoholic KOH, and the final product you get is alkyl isocyanide and KCl and water as the side product. This RNC is known as alkyl isocyanide or alkyl carbylamine. Alright, so both the names are correct. So this is what the product looks like. Now let us see some examples of carbylamine reaction. So you see that this is the first example, ethylamine. Alright, and reacting it or heating it with chloroform and alcoholic KOH, you will get ethyl isocyanide, KCl and water. Alright, so the simple way to predict the product is that simply remove the NH2 group with the NC group. Alright, you see in the final product there is nothing much difference. You simply remove the NH2 group with the NC group, or you simply replace the NH2 group with an NC group. So this is particularly a trick to directly predict the products. Alright, let us see the second example. Here I have taken aniline, alright, or C6H5NH2 phenylamine, alright, and heating it with chloroform and KOH. So what you will get according to the trick, simply remove the NH2 with NC. Alright, so see, same thing has happened, C6H5NC, alright, phenyl isocyanide. Okay, so this is the product, KCl and water as the side product. Now let us see the third example. You see this is also a primary amine because only one hydrogen of ammonia has been replaced by this alkyl group, right? It is also a primary amine. So by reacting it or heating it with chloroform and KOH, you will get again the same thing, that the ammonia will be replaced or the NH2 group will be replaced by an NC group. Alright, so you see this is your product, and KCl and water as the side product. Alright, so basically these are the examples of carbylamine reaction. Now let us see the mechanism of carbylamine reaction, because in every organic reaction the mechanism is very important to understand the reaction clearly. Alright, so now let us see the mechanism of carbylamine reaction. So first of all, what will happen is, you see that I have taken alcoholic KOH. So KOH is a base. So what will happen? KOH will give you OH minus. Alright, so that OH minus will react with the chloroform. You see CHCl3. Alright, this is a chloroform. Alright, so the OH minus will react with chloroform, and what it will take? It will take H plus from the chloroform. Alright, and water will be removed off. So what you will get? You will get this ClCl3 minus. Now it is an unstable compound. So what it will do? It will remove one chloride ion. Alright, it will remove one chloride ion and you will get this. Alright, this is a dichlorocarbene. Alright, CCl2, it is a dichlorocarbene and chloride ion has been removed off. Basically in this carbylamine reaction, this dichlorocarbene is the reactive intermediate. Alright, in the carbylamine reaction, this CCl2 is a reactive intermediate. Now you see that this carbon is attached to two chlorine atoms. All right, now you know that in the excited state the carbon is tetravalent. All right, the valency is 4. Now only 2 of the valency has been satisfied by chlorine. All right, 2 is left. So what will happen? It can accept a pair of electrons. All right, this is clear. Now who can give the pair of electrons? Basically the amine we have taken, or the primary amine we have taken, because in the primary amine there is nitrogen. All right, nitrogen has lone pairs, so it can donate the lone pairs to dichlorocarbene. So the same thing will happen. So you see, this is the primary amine and this is dichlorocarbene. Basically it is because it is electron deficient, it is an electrophile, right? It is an electrophile. So what will happen? That nitrogen will give lone pair to this carbon and you will get this. All right, so now you see, because nitrogen has given lone pair, so nitrogen has given electrons, so that's why nitrogen will have a positive charge. Carbon has accepted electrons, so it will have a negative charge. All right, so you will get this product. Now you see that the carbon is still attached to 3 atoms. All right, and that valency is 4. Okay, and the second thing is that the nitrogen is a electronegative element. All right, and it has a positive charge on it, so it is unstable. So to neutralize the positive charge or to remove the positive charge, what will happen? That the nitrogen will remove one H plus. All right, the nitrogen will remove one H plus, so the positive charge of the nitrogen will be neutralized, and because the carbon is attached only to 3 atoms, so it will make a bond with that hydrogen. All right, to complete its tetravalency. All right, so that same thing will happen. You see this. All right, you see in this the hydrogen has been removed from nitrogen and it has been bonded to the carbon atom, because carbon atom need to fulfill its tetravalency and nitrogen has to neutralize that positive charge. So this reaction happens. All right, now because I have told you in the beginning that we are heating the reaction. All right, we have to heat the reaction, so that's why now the next step will be that this Cl minus will break off. Now because we are heating it and we know that chlorine is a good leaving group. All right, I am repeating it, because we are heating the reaction and also that the chlorine is a good leaving group, so this chlorine will break off as Cl minus, the chloride ion will break off. So that if the chloride ion will break off, what will happen? This carbon will have a positive charge, will gain a positive charge. All right, now the carbon will gain a positive charge, which means that it is again electron deficient. Now again what will happen? That nitrogen will give lone pair. All right, so this is what you get. All right, now again another thing will happen. Now the same thing will happen, that the nitrogen has positive charge and nitrogen is electronegative in nature, right? So this positive charge is unstable on it. So again what will happen? That it will remove another H plus. All right, it will remove another H plus. So now what will happen? You see, this will be the product. All right, now the above step will be repeated again, and the reason will be the same, that we are heating the reaction and the chloride ion is a good leaving group. All right, or the chlorine atom is a good leaving group. So the same thing will happen again. What? That the Cl minus will break off. All right, the Cl minus will break off, and because the carbon will have a positive charge, so nitrogen will give lone pair to that carbon. So you will get again this. All right, now the thing is that how to neutralize the positive charge of the nitrogen now. Okay, because it cannot break the R. It cannot break the R. It is a strong bond, so it cannot break the R to neutralize the positive charge. So now what will happen is that the OH minus, another molecule of OH minus, which has been derived from KOH, will remove one hydrogen bonded to the carbon atom. All right, it will remove the hydrogen bonded to the carbon atom. So what then it will happen? That if it removes the hydrogen from the carbon atom, so the carbon atom will have a negative charge. All right, the carbon atom will have a negative charge because the hydrogen has been broken off as H plus. Okay, so now the final product is somewhat like this. So you see, the nitrogen has plus charge on it and the atom adjacent to it or next to it has negative charge, so it somewhat neutralizes the positive charge of nitrogen. All right, so now this is the final product. This is known as carbylamine. All right, this NC group is carbylamine group. All right, so now you get your final product, which is alkyl carbylamine, which you will get in carbylamine reaction, or alkyl isocyanide if you want to say. Okay, So now I think there is a bit confusion in the structure of isocyanide. All right. So the structure of isocyanide is a bit complicated, or it is not a bit complicated. It is somewhat different from usual structures. All right. You see, it is a ionized structure. You can say that both the atoms have a charge on it. All right. It is not a completely neutral group, which is somewhat true in other cases also. Like you see in the hydroxyl group, the oxygen has a negative charge on it and hydrogen has a positive charge on it, because oxygen is electronegative in nature, right? So it is not somewhat very different from other structures. All right, so don't get confused on it. So now let us see the structure of carbylamine. All right, so the carbylamine is believed to occur in either of the two structures visible on your screen. So, all right, so I am going to explain them. So you see, in the first structure, see my cursor, that the nitrogen is having 3 bonds. All right, remove the black one. The 3 bonds are 2 sigma bonds, one to R group and one to carbon, and 1 pi bond to carbon. All right, so the nitrogen is triply bonded, so its valency has been satisfied. All right, so this means that the nitrogen can give a coordinate bond, or it can form a coordinate bond. All right, now you see that the carbon is only doubly bonded and the carbon is tetravalent, so this means that it is electron deficient. All right, and nitrogen's valency has been satisfied, so it can form a coordinate bond, which means it can give lone pair. All right, so that is what is going to happen, that nitrogen will give the lone pair to carbon to fulfill its valency. All right, so basically this is how the NC is formed, that the nitrogen is doubly bonded to carbon and one is a coordinate bond. All right, so you can represent it like this also, or you can represent it like this also. How? Because you see that nitrogen has given electrons, so it will have a positive charge. Carbon has taken electrons, so it will have a negative charge. All right, so if you don't want to represent the bond through an arrow, or if you don't want to represent the coordinate bond like this through an arrow, you can also represent it through the charges. How? Like this, because nitrogen has given lone pair, so it will have a positive charge. Carbon has accepted electrons, so it will have a negative charge. All right, and the coordinate bond has been replaced by a sigma bond. All right, so you can represent it like this also, and this is overall a neutral species. All right, because the nitrogen has positive charge and carbon has negative charge on it. All right, so it is a neutral species. All right, so don't need to worry about the charges that it will create instability. It is not the case, because in every functional group in which there is a one highly electronegative element than the other, there is charge separation and there is polarity. All right, so the same thing is happening here also. Nitrogen is more electronegative than carbon atom, so the polarity is been there. In hydroxyl group also the polarity will be there. All right, in carbonyl group also there will be polarity. All right, so don't need to worry about the charge. So basically the structure is somewhat looks like this or either this. All right, so I hope it is clear to you. So that's all for today. I hope you have understood whatever I have taught. If you have understood, do give it a like, subscribe to my channel, and if you have any queries, comment down below. Alright, so now I will see you all in the next video. Till then, this is Akash Shukla signing off.